Alright, let's talk about palindrome partitioning. So you are given a string S, partition S, such that every substring of the partition is a palindrome. Return all possible palindrome partitioning of S. So for this example, A, B, they are all partition, right? So, and also palindrome, and double A and 1B as well, right? So I wrote some function already, so it could save a lot of time. So I have a function called is palindrome to check the string is palindrome. If not, then you just return false. If it is, then I have to increment the pointer, and later I return true. So the answer has to return list of string. So the idea is using BackTrack because you have to check if the substring you traverse is palindrome, right? Is valid or not. If not, then we have to remove, else we keep doing it. So list of lists, and this is temp array, which is list of string, and this is string is given, and I start from 0. Okay, but I need to traverse based on this index, right? If low index is equal to the length of the string, which means we traverse toward the end and is palindrome, then we add to this. So temp is what we store, then we just add. Now you might get confused for the if statement, but I will talk about it later. So high equal to low, you start from low, you start from 0, right? High less than, start length, high plus. Now we definitely need to check the string is palindrome first. If it's not palindrome, as low, high, we don't want to care about it. We only care about the palindrome, right? So now it's the palindrome, right? So let's just add the substring to the temp of list, right? As the substring from low to high plus 1. Why? Because substring doesn't include the last index, right? So the high is from here, but we have to point it here, so you include the second A. So you include the first A. Now we backtrack. We keep looping, and the index is high plus 1 because we already know. We already checked the low, so just high plus 1. Now we have to remove. Why do we have to remove? If we add the substring, that is not the case what we want, because when we add in the next for loop, you will still check, right? You will check its palindrome. If it returns false, we have to delete, right? So this is the case. Why do we have to remove? And we delete the last one because list of the string, when you add to the last one, and when the last one doesn't work, you have to remove. Now let's just check. Alright, pretty good. Alright, cool. Alright, let's talk about time and space for this case. This looks hard, but let's narrow it down. So all of them for the palindrome, right? While less than R, you check every single character. Now for this one, there's a case. You either partition or doesn't partition, right? So you have two options. So when you have two options and you have to keep track of recursion based on your string, which is all of n, then for this case you have all of 2 to the n, right? You either partition or doesn't partition, right? Now 2 to n for this for loop, but in this for loop you have all of n, right? So at the end you have all of n times 2 to the n for the time, and then for the space less than all of n, right? should be okay. I don't know, but based on what you actually store, this is more than all of them. Based on what string you have, I would say n squared for the max. So space will be n squared for the worst case, and then time is all of n times 2 to the n. I'm going to rephrase why all of n for this case, because it's palindrome. 2 to the n for this for loop, because you partition or doesn't partition. You either partition or not partition, right? 2 to the n and all of n. So n times 2 to the n for the time. So I hope you get it, and peace out.